హలో స్టూడెంట్స్, వెల్కమ్ టు Tuteetute. సో టీఎస్ జెన్కో నుంచి నోటిఫికేషన్లో మనం ఆల్రెడీ ప్రిపేర్ అవుతున్నాము. 1 by 1 సబ్జెక్ట్స్ ఆల్రెడీ చదువుతున్నారు. సో చాలామంది నెట్వర్క్ సబ్జెక్ట్ కూడా కంప్లీట్ చేస్తున్నారు. సో ఎనీహౌ టీఎస్ జెన్కోలో 2015లో మనకి ఏ క్వశ్చన్స్ ఇచ్చారని చెప్పేసి చూద్దాము. సో క్వశ్చన్ పేపర్ 2015లో కొంచెం ఈజీగా ఉన్నింది. ఓకే, సో అందులో ఓన్లీ ఎలక్ట్రికల్ వాళ్ళకైతే సో ఓన్లీ ఎలక్ట్రికల్ సిలబస్లోనే మెయిన్ కాన్సన్ట్రేట్ చేస్తారు. సో ఎలక్ట్రానిక్ సిలబస్ చాలా తక్కువ కాన్సన్ట్రేట్ చేస్తారనమాట. ఓకే, సో ఈవెన్ క్వశ్చన్ పేపర్లో మనం క్వశ్చన్స్ చూస్తే ఎంత సింపుల్గా ఉన్నాయనేసి మనకు అర్థమవుతుంది. ఓకే, సో లెట్స్ సీ ద ఫస్ట్ క్వశ్చన్. ఇన్ ఏ సిరీస్ RLC high Q circuit, okay, the current peaks at a frequency. Okay, so current maximum అనేసి అడుగుతున్నారు. Okay, so current, so I will be maximum. So where it is in a series RLC circuit. Okay, so no need to think. So when the current will be maximum, so during resonance condition. Okay, so during resonance condition directly we have to answer. Okay, so when the frequency is equal to the resonating frequency, so that's what directly we have to answer that question. But so we need to understand something more from this question, right? Okay, see, somebody may check for the answer only. Okay, so you can skip the explanation part if you want. Okay, see, whenever in a series RLC circuit they have mentioned, okay, so R, L and C. Okay, so in a series RLC circuit, so they have mentioned so high Q. Okay, so why they have mentioned high Q? High Q means so Q will be more, and this means the Q factor will be more. Okay, so Q factor is more means omega L divided by R. That's what they have mentioned. So it may be so L value is more or omega value is more. So that like that it will be possible. Okay, so they have mentioned about high Q. Okay, so that's why so omega we need to consider here. Okay, so why this omega we need to consider? This is changing one. Okay, so omega is changing and Q factor is high means definitely at certain frequency you will be getting a resonating condition. Okay, so that's why they need to mention this. Even if they don't mention this Q also, okay, so no need to worry. Okay, so directly without this analysis also we can understand. Okay, so this is the source. Okay, so V of t it is. Okay, so V of t it is, and here we have R, L and C. The reactance, otherwise impedance of resistance is directly resistance only, and for the inductance it will be omega L, and for the capacitance, so let's take J omega L. Okay, so and for the capacitance it will be minus J by omega C. Okay, so this is the one. So what is the resonating condition? Whenever inductive reactance is equals to capacitive reactance, that means omega L is equals to 1 by omega C. So at this condition resonance will occur. Okay, so during resonance condition the entire impedance. Okay, so what is the impedance? Impedance generally we need to give it as R plus J into omega L minus 1 by omega C, because this is a series circuit. Okay, so this is the complete impedance, R plus J omega L plus minus J by omega C. This is the complete impedance. So under resonating condition what will happen? Omega L is equals to 1 by omega C. This imaginary part will become 0. So impedance is equals to resistance. This is also one of the bit. Okay, so during resonance condition the impedance of the network is equals to the resistance. Okay, so whenever resistance, only resistance we are getting previously in general, so Z equals to R plus some more value. If you take the magnitude of this one, under root R square plus omega L minus 1 by omega C whole square, that is the complete one, but remaining all term is not present now. So what will happen? Z value decreases during the resonating condition. Okay, so impedance decreases. When impedance decreases, what is the current going in this one? I of t is equals to, so I of t equals to voltage V of t divided by impedance. Impedance decreases, current increases. Okay, so when it will be maximum? During resonance condition. Okay, so directly, so all this, so many points are there here. Okay, so even what is the voltage across this? What is the voltage across this? Okay, so AC only. So what is the voltage across this? What is the voltage across this? These are also some of the points. Okay, so anyhow answer is equal to the resonating frequency. Okay, so next question. Two port networks are connected in cascade. The parameters of the network are obtained by. Okay, so parameters they have mentioned. Which parameters they didn't ask? Okay, see the question. So what they have mentioned is the two port networks are connected in cascade connection. What is cascade connection? If this is one two port network, two port means two ports. Okay, input port and output port. So and this is another two-port network. So cascade, what is cascade connection? So cascade means end-to-end connection. Okay, so this is cascade connection. Okay, so this is two-port network 1 and this is two-port network 2. So whenever two-port networks are connected like this, the ABCD parameters or transmission line parameters or T parameters of this one. Okay, so ABCD parameters or T parameters. Okay, so of this one and this one. Okay, so both, so A, B, C, D, A, B, C, D. Okay, so this is for the first one, A1, B1, C1, D1. This is for the second one, A2, B2, C2, and D2. Okay, so these are the two different matrices. Okay, so for this one separately this ABCD parameters, for this one separately this ABCD parameters. Whenever you connect like this, what will happen? The complete ABCD parameters are otherwise the complete T parameters is equals to T1 matrix multiplication T2. Okay, not normal multiplication. This is a matrix multiplication. Okay, so that is also a one of the previous year bit. Okay, so matrix multiplication. Okay, so matrix multiplication, so if you don't know, so you need to learn that matrix multiplication. So it's simple only because you have completed some mathematical methods and so many times we will be practicing this. Okay, so matrix multiplication. Okay, so matrix multiplication we need to do. Okay, so what is the answer for this one? The parameters of the network are obtained by multiplying the individual ABCD parameter matrix. Okay, so here this is cascade connection, right? So this is cascade connection. So whenever you connect in series connection, okay, so whenever you connect in series, two-port networks are connected in series, then which parameters? So Z parameters of that network equals to Z1 first one and second one. Okay, so Z1 and Z2, both matrices we can add, or both individual parameters also we can add. Okay, so here someone may get, okay, so like a combined A parameter is equals to A1 plus A2. Okay, so that means individually, so can we add like this? Means this is wrong. Okay, so we cannot do like this, only matrix multiplication we have to do. But here in this one Z11, in this one, so Z11 of the first network and this is for the second network, we can add. If you want complete Z11, you can do like this. Okay, here individually we can do. Okay, so whenever two-port networks are connected in parallel, okay, so parallel, so don't ask me what is series connection and parallel connection. Okay, so how we have to connect these things we will learn in the class. Okay, so anyway, parallel connection, then Y parameters similar to like this, Y parameters we can do. Okay, so that's what the analysis. So anyhow, okay, so for the 4 parameters, definitely from two-port networks you will definitely get one question. Okay, so next question. So a network contains linear resistors and ideal voltage sources. If values of all the resistors are doubled, then the voltage across each resistor will be. Okay, so no need to think more about this question. They have mentioned it contains linear resistors, ideal voltage sources. Okay, so let's take only one voltage source. Okay, so this is 10 volt and here, so many resistors are only one resistor, you can consider anything. Okay, so this is 1 ohm and this is also 1 ohm I will take. Okay, so what they have mentioned, so now if you check between the voltage, between these 2 points voltage is 10 volt, between these two voltage is 10 volt, what they have mentioned, then the voltage across each resistor will be when it is, if the values of all the resistors are doubled. So if for example same circuit only 10 volt voltage source is like that only, so and here 2 ohms is there and here also 2 ohms is there, so then what is the voltage between these two? 10 volts only, between these two 10 volts only. Okay, so no need to do all these. Okay, so if we have practice, so then directly we can answer this. Okay, so next question, the number of independent loops for the network with a n nodes and b branches is directly b minus n plus 1. Okay, so we need to directly answer this question. So otherwise independent loops, you may confuse here. Independent loops means the mesh. Okay, so number of meshes in the network, otherwise number of equations to solve using a mesh analysis. Some more questions also they may give. Okay, so if you want to do the network analysis using a nodal analysis, how many equations you need? nodal analysis. Okay, so you need to do np minus 1 number of equations. You using a mesh analysis, you have to do so number of mesh, that many equations using mesh analysis. Number of mesh means number of independent loops, that will be b minus n plus 1. Sometimes they may confuse like this. Okay, so n minus b plus 1, otherwise b plus n minus 1, so many things they will give. Okay, so you should not confuse. Here options are not like that, so directly you can get. Okay, so next question. A DC voltage source is connected across a series RLC circuit under steady state conditions. The applied DC voltage drops entirely across. Okay, so anyhow, so we have already drawn this series RLC. Okay, so R, L and C. Okay, so this is the one, and they told here they have connected a DC source. Okay, so DC voltage source they have connected. See, this is DC. Okay, so whenever DC source we have connected, so what is the frequency? F equals to 0 for the DC. So resistance anyway for DC or AC, resistance value will not be changing. For inductor, okay, so inductor, so J omega L, so J omega L. Okay, so this is the inductive reactance. For the capacitance, minus J by omega C. Okay, so if F equals to 0, frequency equals to 0, so angular frequency is also equals to 0 omega. So then the inductive reactance will becomes 0 ohms, and the capacitive reactance will becomes infinity ohms. Okay, so that means this entire network, whenever you connect DC source across this entire network, okay, series RLC circuit, inductor will act as a short circuit and capacitor will act as open circuit. Okay, so this is the final conclusion only. Okay, so how they are acting like that means it has stored some energy, it is also stored some energy. After that they will act like that. Okay, so they can take more energy after that. Okay, so that's what it means. If it is AC, they will be charging and discharging, charging, discharging. But if it is DC, so they will be charged, and after that they can't charge more, and they will act like so capacitor acts like open circuit and inductor acts like okay, so short circuit. Okay, so anyhow the circuit will become like this. Okay, so this is voltage V, this is resistance R, and inductor will act as a short circuit and capacitor will act as open circuit like this. Okay, so whenever it's open circuit, see whatever voltage is there here, so current will not be going inside because there is open circuit. So voltage between these two terminals will become as directly V. That means what they have asked, the applied DC voltage drops entirely across the capacitor only. Okay, so only at the capacitor you will be getting the voltage V. Okay, so that's the answer. Okay, so anyhow GENCO 2015 they have given only 5 questions. Okay, so anyhow generally 7 questions. Okay, so from the network analysis you will be getting. So here they have not given any question from the transient analysis. Okay, so and even resistance reduction methods also they have not mentioned. Definitely these questions will be there. Okay, and remember from the bridges. Okay, so from the bridges definitely one question may come. Okay, so from the bridges, that's why we have uploaded that in the YouTube. Okay, so like this, so other subjects also we will be giving all the GENCO question paper, so including that remaining 20 questions also. Okay, like 100 questions we will be uploading one by one. Okay, so subject by subject we will upload. So because if you didn't subscribe yet, just subscribe. If you want online coaching or anything, just call our numbers. Okay, so you can take the online courses. So and one by one subject like measurements, power systems, power plant engineering. Okay, so these all I will be taking, and remaining different lecturers will be taking that. Okay, so anyhow, so this time question paper may not be this much simple. Okay, so there will be somewhat tougher questions, and these are all like conceptual based questions only, but they may give some circuits also, some typical questions also they may give in the examination. Okay, so anyway, all the best. Thank you so much.